Woo! Show of hands. How many people here have ever been involved in any kind of software development project? Just about everybody here, right? Who here has been involved in an agile development project? Just about everybody here. Who here, despite using agile and all that agile goodness, has still managed to go over budget or over time or screw something up? Right? Way too many people. That's what we're here to talk about. Why 15 years after the invention or the introduction of agile, why we're still screwing things up so badly. Why the art of software development is still so unpredictable. So first of all, who am I and why am I talking about this? My name is Assaf Weinberg. I'm a developer here at Skookum. I've been developing software for about 15 years now. And over that time, I've worked at 12 different companies. Some of those companies were big, like GE. Some of those companies were as small as 3-person startups. And while the people and the companies and the experiences were kind of different, there was one common thread that ran across all of those experiences. And that was this consistent and predictable gap between how people think software is developed and how it actually is. So this gap that I'm talking about between what's expected and what's necessary, it's the biggest cause of tension between developers and managers, between developers and clients and stakeholders. It's the biggest cause of chaos among development teams. It prevents managers from asking the right questions, and it prevents developers from giving useful answers. I mean, when you ask a developer a question, what do they say? It depends. So a lot of times we end up asking the wrong questions, so we don't get very high value answers. And in the worst case possible, developers sometimes check out of the process entirely. They just give up and stop communicating altogether. And we can't really have that. So what's this gap that we're talking about, and where does it come from? It comes from the idea that software is construction. So if we kind of step back, go back several decades, when we first started writing software, and we first started having to manage that process, it was new to us. We had no idea how to do it. And we do the same thing that everybody does when they run into something that they don't understand. We just mentally map it to something we do understand. And in the case of software, that just happened to be construction. Has anybody here ever built a house or been part of a construction project? Yeah. I get the pleasure of doing this last year, and it is a pain in the ass. So the basic process, I mean, it's kind of predictable. You start with putting together a list of items that need to be built. You then assign an estimate, a cost estimate, to each one of those items. Then you start working your way down the list one by one after another. And along the way, you check off the items as you pass them, and you check each one for defects. If there's any defects, you fix those things, and you move on. This is a great metaphor, or at least we want this to be a great metaphor, because this means that software is linear, it means that software is incremental, and most of all, it's predictable. I mean, managers, this is what we want. We want a predictable process. We want this metaphor to be true so badly. This metaphor is so good that it even teaches us how to think about skilled labor, how to think about developers. Developers in this metaphor are just digital construction workers, right? They're commodity labor that's capable of producing a fixed amount of output per hour. You could just add more to make the project go faster. You could take some away to make the project go slower. You could even interchange them without losing anything. You know, you have a welder on a project, you just take them off, put a different welder on, and he picks up exactly where the last guy left off. This is great, right? I mean, we have predictability, we know how to understand it, we've been doing this for thousands of years. You know, we just bought this metaphor wholesale. We just went with it. But has this metaphor actually worked? Now, given our experience in this industry, as we're starting to mature, it's been decades. It's still a relatively new industry, but we're starting to learn and kind of get our own identity. What experiences have we seen that tell us whether this metaphor is true or not? Well, first of all, if development is predictable, like construction, then why are estimates so terrible? I mean, developers are notoriously terrible at giving estimates. Are they just stupid? Can they just not figure it out? Or is there something wrong with the question itself? Second of all, if the work is incremental, then how come adding more developers or doubling your development staff doesn't end up doubling your output? As a matter of fact, sometimes adding more developers even makes your output slower. It reduces your output. And long before this book was written, we already knew that. So we've known this for a long time. But we've chosen to ignore it. Also, if developers are interchangeable parts, then how come outsourcing hasn't worked nearly as well as it has in manufacturing or in manual labor? We've done a lot of outsourcing in the past decade especially, and at best, and I'm being really generous here, we've gotten mixed results. It's not been a huge raging success like it has been in manufacturing. If it's been a great success, then every single piece of software you get would have Made in China written on it, but it's not. And last but not least, a lot of people talk about developers as factory workers. But if that metaphor is true, then think about what happened in manufacturing. As innovation came in, as machines came into the shops, they started replacing some of the manual labor, and those people lost their jobs, and you got chronic unemployment. In development, or at least in software, think about how much automation we've had in the past decade. Stuff that you would have to hire a custom software developer for 10 years ago, you would just go to Facebook or go to Tumblr or just sign up for an account somewhere. We have an unprecedented amount of software off the shelf. Yet today, we see more demand for developers than ever. Bottom line, we have an enormous metaphor fail. It just doesn't add up, and we can't keep pretending that it does any longer. By the way, my favorite part of this video is this dude right here. Yes! Metaphor fail. So, if construction isn't a good metaphor for development, then what is? How about invention? Well, let's see. What does an inventor do? What is invention? An inventor designs something unique that's never existed before that performs a specified function. Their challenge is to figure out how to do something and then document that knowledge in a patent so that a factory or somebody else can execute on it and build it. Their work is unique. So just to be completely clear, this plane here, this is not an invention. The patent that describes how to build the plane, that's an invention. So how does this apply to software development? Well, first of all, everything a software developer does, a custom software developer does, is unique by definition. If it weren't unique, then nobody would hire them to do it. They would just buy something off the shelf. So the problem they're solving is unique. Second of all, the developer's challenge is also to figure out how to do something and then document it. An inventor documents their findings in a patent. An inventor documents their findings or their solutions in code. If you think about it, code is nothing more than an unambiguous specification of how something works. Just like a patent could then be used by a factory to create any number of planes, infinite planes, that knowledge only had to be created once. A piece of code can be executed infinite times by a computer to create infinite instances of that software. So the work that they're doing is a unique invention that's never before been done. And I promise that's as deep as that metaphorical rabbit hole is going to go. But bottom line is that software development is a design process. So let's say you buy this. Let's say, just kind of come along with me here and accept this as true. If software development is a design process, then what does that mean for the current processes that we use to design software today? So you can't talk about software development process without talking about Agile, or more specifically, Scrum. Because when you say Agile today, what people really mean is Scrum process. And I could fill an entire book on the tragedy, which is that mix-up over there, how Agile, a philosophy of software built on not having specific processes, became personified by a dogmatic practice, or a dogmatic process. So that's not the point. The point is that today Scrum is considered the gold standard of software development. Every development team tries to implement Scrum and tries to implement it as closely as possible because that's the state of the art. But if development is like invention and Scrum is the best process to develop something, then shouldn't we be able to invent something using Scrum? Shouldn't Scrum also be the best process for invention? Well, the transitive property, it's right? So what do you guys think would happen if you tried to invent something using Scrum? Well, I've got a guest here today. Coming to us from the 1800s is Thomas Alva Edison. He is history's most prolific Scrum Master. And he's going to teach us, or he's going to let us watch as he invents the light bulb using Scrum. So, by the way, first of all, do all you guys know what Scrum is? Basic idea. It's a process by which you take the full project, break it up into stories, individual user-facing features, assign points, and work through it in sprints. Anyway, we'll get to see more of that. Back to Tom. Tom's going to invent the light bulb. First thing he does, like a good Agilista, is he puts together a backlog of stories. Each one of them is user-facing. It provides specific user value. And then he assigns points which represent a level of effort for each one of those. We're all set up and ready to go. Sprint number 1 kicks off. The first story he plays is, as a user, I want to turn on the light so that I can read. Well, Scrum teaches us to do the least amount of work possible in order to provide that user benefit, the smallest increment possible. Well, Tom makes an architectural decision, and he goes ahead and uses fire. Bam, there we go. 1 down. We've got velocity. We've got momentum. On to story number 2. As a user, I want to turn off the light so I can go to sleep. Well, we've already made an architectural decision to use fire, and we need to do the least amount of work possible to solve the story. So it only stands to reason that we extend our architecture and add water. So here we are, 2 sprints in. We're trying to invent a light bulb, and we have a fire and a bucket of water. How's this going so far? This going well?
Making good time.
Yeah. Patty, how's this going?
You know, I feel like we might be maybe meandering a little bit on here, but you know.
Possibly, but that's just your opinion.
Yeah.
Because according to the burn down chart, we are kicking ass. This project is rocking it, okay? We're 2 weeks away from inventing the light bulb. Right now, think about what's going on. The client is getting excited. They're going to have a big reveal at a conference. They're putting together a press release. Tom's looking forward to the big raise he's going to get when he pulls us across the finish line. Everybody has this expectation that we're almost done. We're almost there. All Tom has to do is just pull this thing over the finish line, and he's golden. So, moving on to the last story here. As a user, I want continuous light for 40 straight hours. At this point, Tom realizes he might have made some poor architectural choices along the way. He realizes that the right move here is to refactor. But think about it. That's not so easy. Think about the situation he's in right now. He has the expectations versus the reality. He has expectations that this project, his clients, his project management team, even he himself, think that this project is 90% done. But it's actually 0% done. He's no closer to having invented the light bulb than he was when he first started. What does Tom do? He's just a developer. How does he reconcile that gap? Does he walk into does he call a big meeting with the project team and walk in there and say stuff like, we need to refactor, or technical debt, or all sorts of crap like that developers say that nobody ever listens to? It's not going to work. Nobody's going to listen to that. There's just too much on the line. The expectations gap is too big. He can't reconcile it. So he does the only thing that he possibly can do. He extends his architecture and finishes the last story. And there you have it, the light bulb MVP as delivered by Scrum. That sucked. So, what went wrong here? What do you guys think went wrong here? Anybody?
Compartmentalize the requirements.
Yeah, that's definitely part of it. if you look back at our metaphor and how we thought about development and what Scrum is based on, Scrum is based on the construction metaphor. And the construction metaphor says progress can be measured by the number of features built. And that's the metaphor that the project team's been using. That's the metaphor the client's been using. So they're watching one thing go up and up and up, the number of features built. Invention, on the other hand, is a creative process. Invention is about solving a problem. So invention, progress is measured by solutions discovered or solutions delivered. These two different things, that's where the expectation gap comes from. And that's what we have to eliminate. So obviously, Scrum is not how invention is done. So how is invention done? Well, best way to find out, right? Ask an inventor. So, not this guy though. We've already seen what he has to offer. Go home, Tom, you're drunk. We asked this guy. This is my dad. Besides being an authority on many things, he's an inventor. And I basically grew up watching him invent things. He's a mechanical electrical engineer. He'd invent stuff and then try to start businesses around them. And he's basically doing startups before they were called startups, back when they were called businesses, you know. Anyway, so I sat down with him and asked him, what process do you go through? What do you do to try to invent something? And he said, well, the answer's pretty simple. It's kind of a 3-step process, generally speaking. You know, step 1 is to brainstorm different ideas different approaches you could possibly have to solving this problem, and find the idea that you think has the fewest and most solvable risks. Step 2, take a look at those risks in isolation and ask yourself, how do we solve each of those risks? Because if we can't solve one of the risks, there's no point in going further. We have to go back to step 1 and choose a different approach. Step 3, once you've solved all the risks independently, is to put those together into one coherent solution, one prototype, and then iterate on that prototype to try to make it better and better until you have something that's feasible. So right now, a lot of developers do this kind of thing, not this formally, but they do it in one form or another, kind of behind closed doors or by themselves or in their own heads. And that's the problem. Like, this stuff is necessary, but it's not part of the process. It never happens explicitly. So if we're going to create an honest development process, we need to make sure that these activities happen explicitly and transparently with the rest of the team. So how do we create that process? Well, let's start. Step 1 is create a plan. I know this seems pretty obvious, but so few development teams actually take time to plan. They just use whatever technology they've been using, whatever patterns they've been using, or whatever technology they want to use next. They just kind of pick it off the shelf without making any justifications for it. And I mean, why not, right? Scrum's taught us that if we just implement one feature at a time, one user-facing feature at a time, eventually some sort of magically coherent technical architecture is going to emerge like a butterfly from a cocoon. It's just, that doesn't necessarily happen in practice. So this part needs to be explicit and needs to be transparent. So how do we do that? So one thing I think we do at Skookum that's really, really good is I think every single project starts with a technical assessment. So we spend at least a month actually looking at, working with designers, working with product managers to put together a plan of exactly what tools are we going to use, what technology are we going to use, how is it going to be architected and put together, and most importantly, what risks are we facing. So this plays a huge role in closing the expectations gap, because if during development things go wrong or something is not, or a risk manifests itself, everybody knew that was a risk already. We already know what we're going to do about it. It's already been taken into account. So that plays a huge role in closing that gap. Step 2, once you've solved once you've put together a plan, you have this list of risks that you need to deal with. Thomas Edison, when he invented the light bulb, he knew that his biggest risk was that filament material. Everything else, a lot of the other pieces were kind of a given, but that filament material that would burn brightly but not burn out was the key risk. So he tested over 1,600 different types of material before he found the right one. Doing that allowed him to learn early, learn as early as possible so that, remember, if we can't solve one of those risks, we have to go back and choose a different approach. An incandescent light bulb is not the only way to make light with electricity. That just happened to be one of his plans with one particular risk that he thought he could solve. So Scrum, instead of solving risks in isolation, what does it do? It tells us just go ahead and start developing, go ahead and start building it, and you'll run into the risks in practice, and then adjust and change things when you get there. That's what being agile is all about. So there's two problems with that. One is that thin vertical slices of fully implemented production code is a really slow and expensive place to learn. Second of all, the fact that you move forward through this process and you don't know when you're going to hit these risks, you don't know how big of the setbacks are going to be when you hit those risks, that creates false expectations. I mean, think about it like the old Windows blue bar, the installation bar, and it starts kind of going. You think you're almost done, and then it just jumps to the beginning, and it kind of goes fast, and it goes slow, and it jumps all over the place. That's a terrible experience, and that's basically what we're resigning ourselves to when we use Scrum and we don't take care of these risks up front. We need to find a way to make this risk solving an explicit part of the process. It has to be fast, it has to be cheap, and it has to be transparent. So one idea that I've been kind of throwing around a little bit is this thing that I'm calling risk sprints. So imagine time box sprints where we take all the risks that we've identified in the project and try to spend a small amount of time solving those things in isolation. So let's look at an example here. First one, a third-party API that we're going to use isn't complete. We want to eliminate that risk by building an API test suite. What we're looking for is 100% coverage, so that every single one of our endpoints that we need returns data in the right format. We want to verify this before we move down the line. We spend 3 days doing it, and in the end, we find out that only 80% of the endpoints actually have the right data coming back. We're only 80% there. What we've just done is we've just learned something in time to actually do something about it. If we learn this 6 months down the line, we have a huge expectations gap to deal with, and it creates chaos in projects. But we've learned something right now, before production has started. So what can we do, right? We can go back to the development or to the design team and ask them to remove some features that depend on that functionality. We can go back to the client and get them to remove those features. We can talk to the vendor, and we can talk to them about possibly adding some of the functionality to the API. The point is we have time to do something about it. So once we've gone through this and we've solved as many risks as we possibly can, the last step in the invention process is to prototype and iterate. We have to put all these solutions that we've discovered, that we've learned together into one prototype and iterate on it. So we've eliminated a lot of risks, but we still have some risks. So we have integration risk, for example. These pieces work in isolation, but do they really work together? We also have scope change risks, like new things could come up, new information could come up. So the scope could change, or the different APIs could go up or down, or environmental issues could basically change. So we still have to account for this risk. Scrum is supposed to account for this risk by having us refactor after every single sprint, or during every single sprint. But in practice, with developers having to actually deliver features every sprint, there's no time for refactoring. That's not the focus. That's not what we're measuring. So that doesn't end up happening in practice. It gets put by the wayside. So how do we bake this into the process? How do we actually get refactoring to happen? Well, one school of thought says, why don't we add 20% time to our sprints to account for refactoring? I'm not a big fan of that approach. If you add 20% time without specifically earmarking it for this is time for refactoring, then that's just going to get swallowed up by feature time, by whatever else. If you just add 20% fluff to the time, you're just going to get 20% lazier developers. It's not what you want to be doing. So instead, another idea that's out there is this thing called dual track Scrum. So basically in dual track Scrum, you have one team that's focused on delivering features, and you have another team that's focused on, that include developers, product managers, and designers that's focused on coming up with validated user stories. So these stories are things that the customer wants and are technically feasible, so that by the time they're shipped over to the development team or the delivery team, they've actually been vetted out. I think that's a really good idea, and I think that has a lot of potential. But one of the difficulties about it is that it kind of involves the entire. It's a complete company process. It involves a lot of buy-in from a lot of different parties, and it's not the easiest thing to start with. It also might be really expensive. So I think the easiest and simplest thing that we can do is something we're doing here at Skookum right now. It's QA week. So our typical development sprints here at Skookum run 3 weeks. 2 of those weeks are for delivering new features, and then 1 of those weeks is for fixing bugs. And during that QA week, we have an opportunity to fix mistakes early before they become a bigger problem and open the expectations gap. But it's more than just bugs, because during that time when we don't have to push out features, we get to step back and look at the big picture and ask, what architectural decisions are working, what's not working, and what might cause us a problem and open up an expectations gap in the future. And we get to refactor all that stuff during a specific time that's set aside for it. That makes things go a lot smoother. And this big picture view, just keeping that big picture view of software is critical, because that's really the point here, that software is about iterating a design, not incrementing a build. And we all need to understand that. And we need to help our clients understand that too. Once we internalize that and truly get it, and we are able to communicate that, that's what's going to allow us to create honest development processes that focus on the right stuff, which is learning and solutions, rather than just pushing out features. So this topic is actually really important to me. Like I said, I've been working on software for about 15 years now, and about a year ago or so, I got pretty burnt out on the whole thing. What really bummed me out about it was just how misunderstood the entire practice was. And it was just really frustrating to kind of walk into every project already a leg down. And I thought, like, why can't I go do something different, like go open up a sandwich shop or something like totally well understood. But in the end, I kind of realized that frustration that I felt was an opportunity to communicate something. It's a lack of communication from developers to other people who are actually really willing to listen. And this has been my attempt to try to communicate that to you guys, and I hope it resonated. Any questions?
What do you guys do the 4th week?
Go on vacation. No, I'm just kidding. Oh, what's up?
Can you talk a little bit more about that dual agile method?
Yeah, so Agile, what Agile's, or at least Scrum, what Scrum's kind of really good at is, let me step back a second. What we're focused on here at Skookum for the most part is sort of greenfield projects. We do a lot of projects from scratch. It's about inventing something new. But what Scrum kind of excels at is taking existing software where a lot of decisions have already been made and try to extending it and keep on evolving it. So with dual track Scrum, you have one development team which is really focused on execution, and the other team, think about what you did before development started. I guess a lot of the kind of stuff that we do here during engineering. Find out what features the customers actually want, test those things out, build prototypes, test UI. It's all trying to figure out what features are actually necessary, or what features are valuable, usable, and then developers also work as part of that team to make sure that those features are feasible. Developers could even write sample code to try to show how to solve that problem before kind of delivering that to the delivery team, which then just has to execute. Oh, yes.
So how do you answer the inevitable schedule and cost estimate questions?
I think we can still do that. I think you can still estimate things, but you have to estimate the right things. So right now we're estimating features. How long will this feature take to deliver? What we need to be estimating is how long will this solution take to discover? Once you've discovered it, and I'm assuming a lot of people here have experience in working with these projects, you see a very sort of herky-jerky sort of velocity at the individual level. Yes, it looks like it smooths out because in the aggregate, but individuals, they might be able to solve one problem, and then that gives them the ability to execute on 5 different features really, really fast. But it's that one problem that they need, that one solution they need to solve. Does that make sense?
It does, but I don't know how you estimate time to discovery.
The same way we estimate features. Like for example, we talked about the API. We want to know, is this API complete? So we know how long it's going to take us to verify that.
I thought that was great. That was like way more eloquently stated than anything I've ever thought about this. Like I really appreciate what the Thomas Edison stuff, like how you, like the first 2 things you did, you made certain architectural decisions. That completely closed off certain pathways at that 3rd step. I've definitely run into that in projects, like saying, yeah, what we thought would be really easy 3 months ago, like actually we can't do now because of the decisions we made up to this point. And it's really hard to like communicate that across. I did have a question before I started that spiel.
Uh-oh.
So listen, else you don't come back. Oh yes. Your risk sprints were great.
Yes.
Okay, so do you think we could? Because there's definitely risks that can't all be like predicted or discovered before going into it. Is risk sprint something we could potentially bring into our process? Like once we get so far, we learn new things on the project like 2 months in. Like instead of doing a feature sprint, let's do a risk sprint. Like go back to the ground floor, like get the product team, get the design team in.
Yeah, definitely. Essentially, what dual track Scrum is doing is, what the development team in the dual track Scrum side is doing is running those risk sprints. It's just, I haven't really seen exact documentation. I don't think there's an exact process to dual track Scrum. I think it's just a high level concept. But yeah, I think you have to do those risk sprints up front, and you have to do them as you go along the way to keep on discovering and solving problems that you run into along the way.
I have a question.
Yeah.
Do you think that, like, if you're going to your customer and would you say, we're going to do 3 iterations, that's what this cost, that's what you're paying for? Or do you keep the iteration cycle kind of hidden from your customer? Because if you said we're doing 3 iterations, then you can charge for that. You can say, well, we can go 5 iterations or whatever. Is that something that you think is viable, or is that too complex or too different from what people are used to paying for when it comes to software?
Well, I can't really say on the sales side. Kalani here, you could talk to him about it. He's the sales guru. But I'm glad you mentioned clients and that feasibility, or that how do you communicate this stuff to them? Because to me, that the fact that we don't educate clients well enough up front about what software development's about is that shaky foundation that we start everything on. We give them this expectation that we need to drive forward and measure one thing, while we really need to be doing another thing. So yes. Okay. Can you repeat that again? Sorry.
The technical risk assessment and then the process of discovering what your students need, where do those fit?
So you start with figuring out what approach you're going to take, and every approach has its own unique set of risks. You have to try to see if you can solve those risks. If not, then you might have to go back to a different approach. Does that answer your question?
So then that will really come before you get into the detailed how.
Yeah, exactly.
So it's not going to try to transition.
Yeah.
Could you talk about how we get to the technical strategy?
How do we get the technical strategy?
You say the way you phrased it is that that we kind of start there, right, for the development. But how do we get? Like, how is the technical strategy written?
Yeah.
How do you determine all the things that go in there?
Yeah. So for the technical strategy piece at Skookum, it's mostly led by the product strategists, which are product managers. And they start interviewing clients, interviewing users, trying to figure out what a real valuable and usable solution might be. And the developer, a lead developer that's working alongside them the entire time, we watch and we learn. And I love this. I love being able to actually just sit there and watch and understand all the user motivations and understand exactly why we're making the decisions we're making. Because as a developer, you have to choose the right platform that's going to let you it's not only going to let you execute the exact solutions or that we came up with, but also let you execute possible alternative paths that were also discussed and talked about, and maybe in the future. Like, being informed as a developer lets us create such a better technical strategy. And the product strategists, they create one document for the product brief, and then the developers create a technical strategy of how to execute on that. We try to explain as much as we possibly can about what software we're going to use, what tools, why we're using those tools, maybe even explain exactly what the decision matrix was and how we weighed each one of them. Because we have time to do this, because we don't have to push features all the time, it really gives us an opportunity to do an in-depth preparation for development. Does that answer the question? Cool.
That's where we identify most of the risks that will be addressed in a risk sprint. Is that kind of what you're...
Exactly. I mean, every single tech strategy that I've written has a section that lists out these are the risks. And as a developer who's come up with the technical strategy, you know exactly where the weak points are, and you know exactly what things you don't quite know are going to work, or some things might break on you. And taking those risks and actually being able to write code against them is going to be really valuable. And about the risk sprints, it's not just about documenting the conclusion. It's also about having sample code written that actually executes and runs and demonstrate what the solution is. Hopefully that'll be really valuable to the development team. Yeah.
I just want to say I agree with this guy. It was much more enjoyable than that.
I gotta change that title slide, man.
Think maybe Tesla next time, you said.
Yeah.
But I'm curious as to whether you or Skookum is actively trying to promote this development as a design process concept widespread as a replacement for the Scrum model instead of Product Management.
Yeah. So are we trying to promote this idea as a company? Not yet. Hopefully we will be, but no. Right now we are very agile, so we do some of these things kind of ad hoc as necessary. And I think that kind of works out pretty well, but I don't think it's been formalized in this way yet.
It sounds a lot to me like design thinking, but for software.
Exactly. We talk about software being a design, or the entire process. Starting with design and then moving on to development. It's like aim, then shoot. And that's not true. That's an illusion. It's the entire thing is a design process, start to finish. And the people that are involved here should also be involved here. The people that are involved here should also be involved there. Like I said, I've worked at a lot of different companies, and the best software I've ever seen written was written by cross-disciplinary teams who were involved from start to finish and were bought in to the entire process. No amount of sprints and stand-ups and whatever else make up for that. Yeah.
It seems like Scrum claims to prioritize the riskiest and hardest things to the sort of like your medicine. Do you find that in practice teams just don't do that?
Well, Scrum prioritizes features a lot of times by importance of the feature. It's a very user-facing approach. So sometimes you start building kind of important features which don't really represent the key risks. Imagine Edison started building at the wiring, at the base, I'm going to polish off this base, it'll be nice and shiny, got some screws in here, got my name on it, before he even knew that he could create an incandescent light bulb. It's just a waste of time to do all those things that you can do without attacking the things that you don't know you can do. Does that make sense?
Okay. I'd like to quick add that Assaf, when he first started talking about these ideas, he wrote a post that's on Medium, the Skookum blog, that you can check out. And also, this will be on the Skookum website in a few days or next week or something like that, to share with your colleagues and other people that help join the revolution.
Thank you, Dustin. Thanks, guys.